So how many of you were able to solve the problem that I gave you yesterday with regards to K-map, right? I think Sayan had posted his workout. And Sayan, what was it? Y bar, W bar, W,
Sir, I got y bar w bar plus yz. Sorry, wz.
uh, W bar, Y bar plus WZ.
Yeah.
Okay, that is fine then. Okay, that's correct. Y bar, W bar plus WZ. Yes, that's the answer. Okay, fine. So I think by now you all are very much aware as to how to solve a four variable K map, right? So let me just pull up the notes and we will start our discussions. So any doubts you have with regards to, have all of you solved it? Any doubts, please ask. It's actually based on how you group the ones. So if you get more number of ones, then you will be actually getting a simplified equation. If not, then once you get an equation, you will have to go ahead further in simplifying it. Okay, so just look into it. uh, Better you get more number of ones so that you don't have to simplify once you get the equation. Okay, fine. So today we will also just look into a few more examples on them. Uh, slowly we will move on to five variables, and I'll be also giving you some problems. Okay, just like how I gave yesterday. Same thing will be given, and you can solve it and try and understand as to how it is done. Okay. So just a moment while I bring up the notes. So I hope you know we had reached the five variable. Yeah, so we have a 0 0 0 1 1 1 1 0, and this combination here. And yeah, one of you were asking if it's necessary to remember. Yes, it is good, so that you will at least if not at least you can remember this this sequence here. Of course, 0 0 0 1 1 1 1 0, this you all remember. For the three bits here, okay, 0 1, okay, 3 2, then 6 7 5 4. Okay, if you can remember this sequence, then It will automatically all these squares you can fill in. Okay, that shouldn't be a problem. Okay, so we spoke about the number of literals here, right? And okay, now can you all uh, I think we discussed even this yesterday, students. We discussed this also, right, in previous class.
No, no, sir.
We didn't. Okay, fine. So we will see one problem here, and then I will give you another problem for your workout. Okay. Now let us see this function if a, b, c, d, e. Okay, so I have a clue that it is about 5 variables. Okay, then I have summation and the numbers inside. So what I'm going to do, as usual, I'm going to just put it as high. Okay, I have written in pencil here so that it becomes easy for you to understand as to which cell to highlight. Okay, which is to be taken as high, and accordingly, see 0 for example, I have given it as 1. Similarly, 2 is given as 1. Similarly, 4 is given as 1. Okay, so accordingly we just fill it up. I want all of you to make note of this. Okay, so that it will be easy for you to understand. Is it visible or should I still zoom in?
It is visible, sir.
Fine, thank you. So just take note of this problem and try to work it out. So you are going to see a different kind of grouping here. I've taken a different example, okay, so that it becomes easy for you to understand. So all types of cases I have taken into consideration, wherein you will know how to group the ones. More number of ones, the best equation you get, the most optimized equation you would get. So that's our idea. So once you're done, let me know and we can proceed. So here, as you can see, I have taken 8 ones. Okay, so 4 ones are here, 4 ones are here. So if I fold my map, okay, according to this line here, with reference to this line, so I will be getting a group of 8 ones, 4 from here and 4 from here. Okay, and ultimately this is going to fetch me equation BE. Similarly, I can get 2 ones from here and then 2 ones. I can group them. Okay, so that gives me a group of 4 ones, and this is the equation. See, you can see that if there are 8 ones here, I'm just getting 2 variables BE. Here it's 4 blocks covered. Okay, group of 4 ones, so I'm getting 3 variables here. Okay, so the more number of ones you get, okay, the more grouping that you can achieve, the best equation you can get. When I say best equation, less variables. Okay, fine. And similarly, you can see another group which is created here, 1 1. Okay, and this one and this one also comes with one group. Okay, so if you take this into consideration, okay, 0 0, which means a bar b bar, there's no doubt about it. Okay, then you take all these here. Okay, I have written here 0 0 0, then 0 1 0, okay, 1 1 0, and 1 0 0. So here I have 0, 0, 0, 1, 1, 1, 1, 0. So this thing gets cancelled out, right? So this thing gets cancelled out, okay? Because we have 0, 0, 0, 1, 1, 0, 1, 1. So everything gets cancelled out. So what is remaining? The remaining part is only my E bar, okay? So this E bar is actually coming here, okay? And we have 0, 0, which is A bar, B bar, that comes here, okay? So ultimately this becomes my final equation. So I just add them together, okay? I put them all together and that becomes my final equation, which is nothing but BE plus A D bar E plus A bar B bar E bar, okay? So a complex equation like this, okay, can be reduced to its simplest form, okay, such as this. So using our grouping techniques, okay, we should be very careful when we are grouping so that we get the maximum number of ones. Is that clear, students? Any doubts here? Any doubts you can ask?
Sir, could you explain that A bar, B bar, E bar, sir?
A bar, B bar, E bar. Okay, fine.
Sir.
I will. So you want to know how we got A bar, B bar, E bar, or you want to know how we have grouped it?
Yes, sir. How A bar, B bar, E bar?
How we have got the equation, right? Okay,
Yes, sir.
fine.
Grouping also, sir.
Okay, I will. Rest of the things are clear, right? Okay. Now, since we have all the ones along this line, right? So everything is along this line, well, or you can consider this row. So what I should do? I should consider 0, 0. So when I take 0, 0, what is happening? It is a low A and a low B, which means A bar, B bar. So this thing is clear. A bar, B bar is clear, right? Because it is in this row, okay? So there is no option for me to cancel out. There's no other combination, right? Because it's only in one row. All these ones are in the single row, okay? Now consider this which I have drawn here, okay? This one, okay? All these are picked up wherever there are ones in the respective columns, okay? This one, here, and then here, okay? All these are picked up and I have written it here. Any doubts till here, students? Till here, any doubts?
Sir.
No, sir.
No. Okay, good. And then my next process is what? To cancel out, right? So I have told you whenever there is 0, 0, 0, 1, 1, 0, 1, 1, I have all the four combinations, which means this thing gets cancelled, right? So can I cancel 0 with 0? Is it possible? I need to have the opposite one, right? Students respond.
Sir, we can't cancel.
Yeah, we can't cancel out, right? So the whole 0, okay, the full 0 that we have here, okay, is actually referring to which one? To E. So E is what here? 0, which means what? Low E. Low E means what? E bar, right? So that E bar is coming here. Understood? Any doubts?
Yes, sir. Understood, sir.
Okay. So we are seeing across this row. So across this row it is 0, 0. So I'm getting A bar, B bar. And then wherever ones are there, those binary numbers you pick and you put it here in the side, just like how I have done it. And once you have here, okay, it will be easy for you to understand. Okay, so the final remaining is only 0. 0 is pertaining to E, so it becomes E bar. Okay, so this is how we are getting our final equation. So I hope it is very clear, and we will move on to the next concept. Before we move on, okay, uh, just take this as an example. T is equal to f of A, B, C, D, E. Not sure if I can write it well. I'll just try out. T is equal to f of A, B, C, D, E is equal to summation 0 to 8, 10, 16, 18, 24, 26. Okay, so
The numbers again, sir.
0 to 8, 10, 16, 18, 24, 26. Okay, so f is equal to, sorry, t is equal to you can take t is equal to f of A comma B, C, D, E is equal to summation, just for the benefit of those of you who have not got the numbers, 0 to 8, 10, 16, 18. For those of you who have got, you can start working. So it's 18, 24, and then 26. Okay, so this is going to be your problem. T is equal to is T is equal to f of A, B, C, D, E. So I have a clue that it is how many bits? 1, 2, 3, 4, 5 bits, and then summation these numbers. Okay, so can I clear it off, students? Can I clear it?
Yes, sir.
Okay, fine. So yeah, so next discussion is going to be product and some simplification. How do we simplify these functions? Okay, simplify the following Boolean function in SOP form. Now I might give you a function, okay, and I might tell you in SOP format you simplify it, or in POS format, product of sum format, you simplify it. So an equation is given, okay, 0, 1, 2, 5, 8, 9, 10, 0, 1, 2, 5, 8, 9, 10. So all the ones are filled in the squares. So once I have filled in, my next idea is to group them, right? So I will take these corners because ones are there, right? So I'll get 4 ones, Similarly, I can get this group here, okay, 2 ones and 2 ones, right? And then my other group is going to be just a group of 2 ones. So this is the equation. 3 equations I'm going to obtain. One is B bar D bar, then A bar C bar D, and then B bar C bar. Okay, I hope this is clear. Now they are telling us to actually use even product of sums. Okay, so we have done it in SOP form, right? Sum of product. Now if I have to do in sum of product, okay, in product of sum the other way, okay, what I have to do is I have to put, instead of 1 I have to put zeros wherever, whichever cells are not filled. Okay, so whichever cells are not filled, there all I will be filling it as zeros. So it is just the replica of this map. Okay, the first map that you see, it is just the opposite of it. Instead of ones you are filling zeros, but not in those places, the remaining places. Okay, so you will be getting an equation, okay, which is AB plus CD plus B bar. Okay, so what we will do here is, okay, we will try to put a bar, okay, and we will be using De Morgan's theorem. Okay, we will split them up, and once we split them up, okay, it becomes A bar plus B bar, and this addition becomes multiplication, then C bar plus D bar. Okay, and this thing here becomes B bar plus D double bar. So double bar goes away, it gives me only D. Okay, now what we are trying to do is we are trying to cross verify. Okay, we will cross verify and we will see if that is what we are getting. Okay, so at 3, yeah, so what I'm going to do is, now see this function here. Let me make it small. Yeah, so this function here 0 1 2 5 8 9 10. Okay, and then see this function here, which is 3 4 6 7. Now remember I'm putting a pi here, right? 3 4 6 7 11 12 13 14 15, all these are with zeros. Okay, so what I'm trying to say here is, okay, I am actually getting an equation, okay, which is equal to what we have got here. Okay, this equation and this equation both are the same. So even though it is pi, okay, which means we are taking the opposite of SOP. So SOP here was 0 1 2, okay, so 3 comes here, 4 5 is here, right? So what I'm trying to say here is, whatever numbers you have here, okay, excluding that, you will be putting those numbers, okay, here. So this is how, if a problem is given, okay, telling simplify the Boolean function in SOP form and POS form, okay, you will be simplifying it in this fashion. So the first one is your SOP form, okay, and the second one is in your POS form, okay, sum of products, okay, and this one is your product of sum. So ultimately, if you get this equation, okay, the final equation here, and then you can actually circle those zeros which are not filled, okay, those squares which are not filled, so those will be put up as zeros, and then you group them, okay, AB, CD, BD bar, okay, and then since it is your POS format, which means it is the opposite of SOP. Okay, so I put a bar, I get this equation. Any doubt, students? See here, AB, CD, BD bar, right? So the same thing we are putting here, and since I want in POS form, I will have to put a bar. So if I put a bar, I will get it in POS form, product of sum terms. Is that clear, students? Any doubts here? Any doubts? You can respond, you can use the chat box. Okay, Surya, thank you for that confirmation. Only thing keep in mind, we are putting ones as usual for SOP form. For POS form, we are putting zeros, and once we get that equation, okay, we have to bring it in POS form. So I have to use a bar. So once I see, if I don't use a bar, what's happening? It is sum of these products, right? So if I have to reverse it, okay, then I have to put a bar to bring it in this form, right? Now you cannot put a bar here, okay? You cannot put a bar for an SOP equation, right? You have to fill the squares which are left out with zeros, okay? Then you get an equation. To that equation you have to put a bar. Now this is important to keep in mind, okay? Fine. 3 4 3. Okay. Now take this as an example, okay? Suppose there is a don't care term here, okay? uh, or I will come back to this problem once we start discussing on don't care, okay? So as of now, okay, what we will do now is we will look into map entered variable method, okay? This is also a different method just like your K-map, okay? We will be studying about this. Sheikh, do you have a doubt? Your hand is raised.
No, sir.
Sheikh Musa? No? Okay.
No, I had no doubt.
Okay. Okay. So now, just like how we studied K-map, okay, we will be studying map entered variable method. Okay. Fine. So let's start. So map entered variable. All of you make note of this. And also, I'll be giving you some problems to solve on it. So in this class, we will just look into what is MEV and what are the rules. Just like how we had rules for K-map, you have to fill them up, fill the squares, how to value the squares, how to fill the squares with ones, and then how to group these ones and how to get a final equation, right? So those were the rules pertaining to your K-map. So similarly, we have some rules with respect to map entered variable. Okay, so we will look into it. Fine. How to find a simplified expression using this method? So let us take y is equal to f of a, b, c, d. Okay. Then now see, we are actually increasing the complexity now. Okay. I have don't care terms. Okay. Don't care a 8, 9, 10, 11. Can someone tell me what is a don't care? I think you would have studied this, right, in your basic electronics. What's a don't care? Yeah. I need responses.
Sir, we consider it only when our expression is being simplified, else we ignore it.
The other way of taking it is yeah, Lokesh. The other way of taking it is, if we want it, we will take it as 1, or if not, we can even take it as 0. Anything, or we can even just neglect it, right? So don't care terms are just don't care. There's no matter. Okay, they don't have any weightage. Fine. So this is plus d 8, 9, 10, 11. Okay, and we have 2, 3, 4, 5, 13, 15. Okay, now how to write this? Now since I have a, b, c, d, which means I have 4 bits. So 0 to 111 I will write. Okay, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 11, 12, 13, 14. Okay, 15. So I will be putting it as this format. Now in the function y, okay, for function or y is going to be our output. So this is where I'm going to give my high ones. So wherever it is 2, so this is my 2. Okay, for simplicity I have even written in the left hand side. So 2 is high, 3 is high, 4, this is binary 4 is high. Okay, similarly 5, and then I come to 13, okay, 15. So this part we are clear, right? Next, that will come to the don't care terms. D is don't care. So 8, 9, 10, 11. So 8, 9, 10, 11. So here I'm going to have don't care terms. So I think now you know how we have created this truth table. Is it clear, students? How is the truth table created from the given equation? Okay, thank you. So we have this output function. This is our step one. Step one is what? Creating a table. Okay, once we have an equation, creating a truth table. That's our step one. We can take one or more input variables as map entered variable. So in this example we will take D as our MEV. Okay, so anything can be considered. I can consider A as my MEV map entered variable, or I can consider D as my MEV, or B or C. So in this example what I will do is I will consider D as my MEV. So now you will understand, okay, as we finish the process, okay, as we finish studying the rules, you will understand why are we selecting an MEV, what is this process, you will understand. So step one, I have created my truth table. Step two, okay, convert the truth table into MEV truth table. So I am modifying my truth table, okay, into a different format. Okay, so what I'm doing here is I am having my MEV. There are some rules that you have to actually know before modifying our truth table. This is going to be our modified truth table. So before you understand this, you should know these 7 rules. Okay, so what are these rules? Rule number 1, if in, and keep in mind I am grouping them in 2 bits. Okay, 2 bits. So if in MEV I have 0, 1, and then my at the output I have 0, 0. What is my output here? Output is y, MEV is D. Okay, so I'll be taking two variables. Okay, two bits. Okay, let me just annotate so it will be easy for you to understand. Okay, so I will segregate it like this: 2, 2, 2. So two bits I will take. Okay, so this is my rule. Okay, so yeah, let's come here. So if I have in MEV 0, 1 and my output is 0, 0, the value to be entered in map is going to be 0. Okay, the value is going to be 0. Next, if my MEV has 0, 1 and my output has 1 and 1, so the value to be entered is 1. Okay, similarly, if I have my MEV, my D bit as 0, 1 and at my output if I have 0, 1, so same thing, 0 is here, 0 is here, 1 is here, 1 is also here. So what I should write it as? MEV. I should write it as MEV. Let's see the reverse case. For 0 if I have 1 and for 1 if I have 0, then I'll write it as MEV bar. Okay. Now here if I have 0, 1 and it's a don't care or a 0, 0 or a don't care. Okay. Now since it's 0 here at the output and it's a don't care, so what I can do is I can totally consider it as 0. Now see the next case: 0, 1, don't care 1, 1, don't care. Okay, So in this case, okay, in this case I'm going to put it as 1. So what are we understanding here is, if I have 0 1 here in my MEV, and if I have 1 here and 1 here, I'll be putting it as 1. Either it is 1 or it is a don't care. Okay, let us say 0 1 don't care 1. Okay, so in that case also I'm writing it as 1. If it is 0 1 and then don't care 1, then also it is a 1. So these are some of the rules. Okay, so can you quickly copy these rules down, so that it will be easy for us to proceed as to how we are developing a modified truth table. Okay, so it's very easy here. When the output is 0, it is 0. When the output is 1, it is 1. When it is 0 1, compare with MEV is also 0 1, I write MEV. When the output is opposite to MEV, then I write MEV bar. When it is 0 or don't care, then I put it as 0. When it is 1 or don't care, I put it as 1. When it is don't care, the final value to be entered is also a don't care. Okay, so mainly you are concentrating on the output, and you're also looking after the MEV bit which is present. Is it clear, students? These rules are clear? Is it clear? You can respond.
Sir, can you explain once again?
Okay, first you look at the output. Okay, output is 0, value also to be entered is 0. Output is 1, you put it as 1. So basically we are converting these 2 bits to 1 bit. These 2 bits is converted to 1 bit. Okay, here I have 0 1, so these are 2 different bits, so I don't have a clear decision. So what I will do, I will look for MEV bits. Okay, now in this MEV bits also it is 0 and 1. So what I will write, I will write it as the output is same as MEV. If it is reverse, then I will put it as MEV bar. Okay, now here I have zeros both the sides, or if there is a don't care and a 0, maybe 0 here and don't care here, then it's going to be 0. 1 here and a don't care here, it's going to be 1. Totally, if both the bits are don't care, then your output, the final value to be entered, is also a don't care. So 2 bits we are converting to 1 bit. Is that clear? Okay, fine, thank you. So now now that we know the rules, okay, we just know the rules now. So now we will implement it on our problem. So we have seen this A, B, C, D. Okay, we have even completed this Y. Now we are entering only the last column. Okay, the last column entry only we have to do. All these we have already seen. Where we have seen, we have created a truth table using this equation, right? So once we have created a truth table, I am just adding one more column here. So to add that column, I taught you these rules. Okay, so this is the column that we have to add. Okay, fine. So now let us see the first combination. So I'm taking D as MEV, as I told you, 2 bits. Okay, I have segregated, I put it in red so that it becomes easy for you to understand, right? Okay, now here, now this is my MEV and this is my output. So I have 0 0 here. So what is my value to be entered? 0 according to the rule. Yes or no? Then I have 1 here. So the value to be entered is 1. Then again I have 1 here. The value to be entered is 1. I have 0 0. Both are don't care. So don't care. Don't care. So again don't care. Now let us come to this case. Now I have a 0 1. It is also same as here 0 1. So what is my MEV here? MEV is nothing but D bit, right? So I am writing it as D. So which means whatever is D, the output is following 0 1, which means that output is same as MEV. Similarly here also I have the same case 0 1, and my MEV is also 0 1. So what is the value to be entered? D. So are you clear with this concept, getting the last column filled, students? Is it clear? Okay, thank you, Surya. So we have created another column, the last column, okay, which is value to be entered in the map. So our next process remains just like how we have a key map. Okay, so the values are taken, okay, 0 1 0 0 0 1 1 1 1 0. Okay, for simplicity what I have done is I have even written it down in pencil: 0 1 2 3 4 5 6 7. Okay, so what is happening here? We have actually 15 bits, isn't it? From 0 16 bits, 0 to 15. Okay, and we are converting it to half of it, which is 1 2 3 4 5 6 7 8. So we have just converted it to 8 bits, right? So these are the bits which actually matters for us. So we will be entering this data here. So this is going to be my 0 1 2 3 4 5 6 7. Okay, so those column values are entered here. Okay, so once we have these values entered, the last step, okay, the last step is important. We have to group the ones with other ones or don't cares. Okay, take note here, take note, this is important, take note. You have to group the ones, okay, with the other ones or don't cares. That is your first rule. Second rule, replace all ones by don't cares. Okay, so what I'm doing here, let us look at step by step. Okay, what is the first step? Group ones with the other ones. Okay, so just look at the table, at the k-map. Okay, now I think I'm audible now. So what we have done is we have grouped ones with the don't cares. Okay, so I have got this equation which is b bar c. Okay, so this a bar, this a gets cancelled because it is 0 and 1. So here it is b bar c, so b bar is what, 0 and 1. Okay, so b bar c. Now I am not grouping the one with MEV. I must group one only with don't care. Okay, so I have a don't care here, and then I have a one. So which means I don't have any other group. So this single one I have to take, and it becomes a bar because it is a0, b, and then c bar. Okay. The next step is what? Replacing all the ones by don't care. So I have replaced ones with don't cares and group only MEV terms. So MEV is here D and D, okay, and it's a don't care. So don't care means I can make it either 0 or I can make it 1. So what I will do is I will consider them fully, okay, and this becomes my final equation A, okay, which is nothing but D, okay, A into D. Why is it A into D? Because A I get here, okay, and D is inside, so A into D. So AD I get from here, okay, B bar C I get from here, and then A bar B C bar I get from here. Is that clear, students? Is that clear? Have you understood? You have to note down this, okay. So the first step is we have an equation. From the equation, we are generating a truth table. Once the truth table is generated, we are applying the rules and converting a 16-bit into 8-bit. So this 8-bit data is entered into the K-map. Once it is into the K-map, I'm grouping ones with don't cares, and then I get some equation, okay. So once I get that equation, I will note it down, and then all the ones I will change it as don't care, and then I will group my MEV variables. So here A is high, so A into D, okay, D or whatever is your variable. Suppose, say example, instead of MEV taking D here, if I have taken MEV and C, okay, then it is going to be A into C. So AC will come here, and these two terms from top, okay. I think that's sufficient for today's class, and we will see in the upcoming class as to how we will solve few problems based on MEV, okay. Fine. So we will all catch up in the next class, okay. Thank you.
Did you